Good morning, class. Today we are in section 3.7, starting a new section, and the section is called Formulas and Functions. A lot of times we refer to these as literal equations. Today we're going to be looking at things that you're not going to have so many numbers in your problems. It's going to be a lot of different variables. When we talk about a formula is an algebraic equation that relates two or more real-life quantities. Some of the most common formulas, I'm going to let you guys write for a second, but some of the common formulas that we know would be things like area equals length times width, distance equals rate times time. There's lots of formulas that you guys probably know. We're going to be taking these formulas and we're going to be trying to find a way to get a different variable by itself. We want to be able to solve for a different variable. So as you take a look at this first example that I have up here, it says area equals length times width. We know that one. Our goal is we want to try to get a different variable by itself because this equation right now is wonderful if I'm trying to figure out what the area of something is given a length and a width. So if I told you the length was 2 and the width of our rectangle was 4, I know 2 times 4 would give me an area of 8. Our goal today, though, is going to be to try to get a different variable by itself. In this case, they want us to solve for the width. So we want to know, what does W equal? We know what A equals. We know A is equal to LW. But what does W equal? So just like in a normal equation, we try to isolate the variable or get it all the way by itself. I want to do the same process, but I want to do this now without having all the numbers. Now, just to show you guys that we can definitely do this, if I put the numbers in, so if I had said, okay, my area was going to be 12, my length was 4, I want to get the W by itself. I want to figure out what W is. If I gave you this equation, I know that you guys would see this and you would say, okay, 4 times W. To get rid of the 4, I need to divide both sides by the 4. And I would find out that W was equal to 3. I know that you can do that process. The weird thing about today is you're not going to have the numbers in there to kind of help you get that variable by itself. There's going to be other variables, just like we have with this A and the L. So if I go back to this example and I say, okay, I want to get the W by itself. W right now is being multiplied by L. So to get rid of that L, to get it away from the W, I'm going to need to divide because that's how I undo the multiplication. So we really need to look at the operations that take place rather than thinking about the numbers. Sometimes it's helpful, though, if you put a number in that place of any other variables, you could see what operations you're going to, or what things you're going to have to do to undo those operations. So if I divide by L, and I know that I can't just do something to one side of the equation, I have to do it to both sides. Anything divided by itself, like L divided by L, they cancel each other out. They become 1. So I have 1W, but notice on the left-hand side I have an A divided by L. And because there's no numbers there, that's just how I'm going to leave my answer. So W is equal to A divided by L. That's how our answers today are going to look. They're not going to be really pretty, just number answers. They're going to have lots of variables in them, and that's okay. So this is what we want our answers to look like. The process of solving is the same process that we've seen before. The difference is that we're going to have those variables now instead. Now I put up, this isn't on your papers, but I put up just a random question or a random problem that has pictures because I want you to realize what we're really doing here is just changing the operations. Notice that I have here that the freshman center minus the Jaguars would only be the Wildcats. Well, if I wanted to solve for the freshman center, I wanted to get the freshman center by itself. I need to look at what's on the same side as the freshman center. Right now it's this Jaguars. The operation that's being done right now is that I'm subtracting Jaguars. So in order to be able to undo that, I need to add because addition and subtraction are going to be those opposite operations. So I need to add a Jaguar to both sides, not just to one side, but to both sides of my equal sign. Now notice that a negative and a positive Jaguar, they're going to cancel each other out. What you're left with is just the freshman center, but your freshman center is going to equal your Wildcats that you had plus the jaguars that we've now added to that side. Now, they're not like terms. We all know wildcats and jaguars are not the same thing. But together, that sum should equal all of the freshman center. So the same process can happen with pictures. It could happen with variables. We're going to be sticking with variables, obviously, because we're in math class. But I want you guys to realize that we're just using those opposite operations. Here we had a subtraction. We had a minus jaguars on this side of the equal sign with the freshman center. So when we want to get the freshman center by itself, we have to do the opposite operation. Because I've got a minus a jaguar, I've got to plus the jaguars to both sides in order to be able to remove them from the left side and put them over to the right side. Same process. Okay, so let's take a look at some more that have the variables in them. In this next example, we want to solve for b. So I'm going to look at what's on the same side of that equal sign as the b. Notice that I've got this a over here. A is being, you could say, added or subtracted. It's not being multiplied to where I want to divide by the a, but we need to do its inverse operation. Right now I've got a positive a, so to remove the a's from this side, I need to subtract an a. But we know whatever you do to one side, you've got to do to the other side as well. The a minus a cancels each other out. What you're left with on this side, if it helps to draw your line, go for it, we have a negative b, and over here we've got a c and a negative a. They're not like terms, so I can't combine them. I'm just going to write it as c minus a. Now, at this point, we're almost done. The b is almost by itself, but notice that right now I've got the negative sign here. You can think about that like a negative 1b. And to get the b all the way by itself, because it's currently being multiplied by negative 1, I can divide both sides by negative 1. Make sure you divide every single term on both sides by that negative 1. The negative divided by another negative will cancel each other out. That becomes positive b, which is what we wanted to be able to solve for, as a positive b. On the right-hand side, notice that I've got my c divided by negative 1. Well, when you're dividing by negative 1, you're really just changing the sign here. This is going to become a negative c, and here I've got a negative a divided by a negative 1, and we know negative divided by negative becomes a positive a. So to get that b all the way by itself, to isolate the b, I know that b is equal to my negative c plus a. Again, looking at that process, I want to remove the a, so that's why I subtracted it from both sides. Then I want to get this b all the way by itself by removing that negative sign. So that's why I divided both sides, every single term, by that negative 1 that was being multiplied by b. Let's take a look at another example. This is the formula that they use to find a player's batting average in baseball. Your batting average is equal to the hits per at-bats, or hits divided by the number of at-bats that a player has. So how could we find out the total number of hits that someone would have? So I want to get this h by itself. So I'm solving for h, is what that's saying. If you take a look at this problem, notice this one's got a fraction in it. That's okay. We know how to clear fractions. The same process that we did before, we're going to use that same process now. We know that when you've got a fraction, to clear the fraction, you want to multiply every single piece in that whole equation by the denominator of the fraction. So I want to multiply my b times my a and my h over a times my a. So on this side, a times b, we can just call it ab. But over here, notice that my a's are going to cancel out. So that's just equal to h. Well, notice that my h is now by itself. So your hits will equal your number of at-bats times your batting average. And that's how we could solve to figure out the number of hits that somebody has. When you notice that you have a fraction in your equation, even if it's all letters, that's okay. Still multiply each term in that whole equation by whatever the denominator of your fraction is. In this case, again, it was the a. So when I multiplied both sides by a, notice a times b was just an ab. But when I take my h over a times my a, that's when my a's are canceling each other out. And that's when I'm left with just the h. for this next one, if we're given an equation of a line in slope-intercept form, which this is a form, the slope-intercept form, oh, just kind of crossed right through that. I'll tell you guys right now, you've probably seen that in middle school. It may not come back to you quite yet. We're going to see this a lot more in chapter 4. So this is something you're going to get really comfortable seeing, this y equals mx plus b. M is referring to the slope. B is referring to the y-intercept. Now, right now, that's not as important as being able to solve for these other variables. So that's what we're going to be doing in this example. For this first one, they've asked us to solve for the m. So I'm going to rewrite my equation. Y equals mx plus b. Notice that if I'm trying to solve for the m, there are some things on the same side of the equation as that m. I've got an x and I've got a b. Now, as you look at those, x is currently being multiplied by m. It's almost like when we talked before about our coefficient is the very last thing that we'll touch. The last thing you ever do is divide. So we want to first remove the b from this right-hand side of the equation. To remove my positive b, I want to go ahead and I want to subtract a b. But I can't just do it to one side. I have to go ahead and subtract a b from both sides of the equation. The b's cancel out. Now notice what I'm left with. They're not like terms. I'm just going to write it as y minus b is equal to my mx. Now my goal is to get the m all the way by itself. So I want to get rid of this x. X is being multiplied by m, so I want to divide both sides by the x. So I want to divide, and each term, not just one piece, but each term, by that x. So I could say that y over x minus a b over x is equal to our m. Notice this piece, we had a couple of steps we had to do. We had to first remove the b, because anything that's added or subtracted will always remove those pieces first. The last thing we want to do is divide by whatever's being multiplied by the variable that we're trying to isolate. We're going to do that exact same process now, but this time we want to solve for the b. So we want to isolate the b. Now, notice that b does not have a number in front or another variable attached to it, multiplied by it. So we don't have to worry about dividing in this case. We want to get rid of this mx. We want to remove it. Now that mx, that's one whole term. Those two things stick together. Only pieces that are added or subtracted move over individually. So this mx, because that's added to our b, that's one stuck together piece. We want to remove it. We're going to subtract mx from both sides. So on the left-hand side, I had a y, now minus mx, is equal to, and all that's left over there is my b. I already have the b by itself. You'll know you're done when the variable that they tell you to get by itself is all the way by itself on that side of the equal sign. All right, we're going to try another one. This one, we're supposed to solve for f. We're supposed to try to get this f by itself. Now, the first thing that I notice here is that we have a fraction, and we know how to clear that fraction. We can multiply both sides of the equation by 9, and that should clear my fraction. Now, I want to multiply everything except for the stuff inside the parentheses. So I know that over here I'm going to have a 9c, but over here these 9's just cancel each other out. So it's going to equal 5 times the quantity of f minus 32. Now, notice on this one, I still have some parentheses. So I can go ahead and actually distribute that 5 times each piece on this right-hand side of the equation. So I've got a 9c is equal to a 5f minus 160. Now, from here, I want to try to get this f all the way by itself. That's my goal. So this one looks a little bit more like a normal equation. I could go ahead and remove that 160. So because it's negative right now, I'm going to add 160 to both sides. So right now I have a 9c plus 160 is equal to my 5f. And I still have one more thing I need to do. I need to divide both sides by that f, or sorry, by that 5 to get that f all the way by itself. So I want to divide each piece by that 5. Don't forget each piece. 9/5, it doesn't actually simplify. It's just going to be a 9/5 c plus, but 160, if I divide that by 5, I end up with 32. That should equal my f. I know that I'm done because the f is all the way by itself on that side of the equal sign. On this next one, notice it says we're solving for the L. L right now is being multiplied by 2 pieces. When it's all one term, we're going to divide by both of those pieces at the same time. So I'm going to divide by WH. Whatever I do to one side, I have to do to the other side. Notice the W's and the H's all cancel. So what I'm left with is V over WH is equal to the L. Now this one looks a little bit weird just because we notice that we're dividing by 2 pieces all at once. You don't need to do them separately. If they're multiplied at the same time, they can be divided at